Okay, so this is notes for 6-5. So I was mentioning to y'all today that x to the 1/3 is the same thing as saying the cube root of x. So for those of y'all that are going on to high level math, in calculus, it's easier for you to do the math if you have it as the 1/3 power. For this class, all you gotta need to know is that these two are equivalent. They're saying the same thing. So just to familiarize you with the notation of the 1/3 power. But we don't do anything with it. There's no benefit in this class for you to have it written as the 1/3 power. So if it bothers you, just rewrite it as the cube root and move on. So the first one, it's not isolated, and I'm going to rewrite it. So it kind of bothers me. And then 2 times the cube root gives me -10, so I'm going to divide by 2. So the cube root gives me -5. So now to get rid of the cube root, I'm going to cube both sides. That leaves me x minus 50 equals -125. So I'm going to add 50 to both sides, and that gives me x equals -75. And I would plug it in and check it. 2 math 4, -75 minus 50. That gives me -10, so that one works out. Check. So number 2 would be very simple if that 2 is not in front. But since it is there, I can't pretend like it's not. So I have a cube root and a cube root. I can't isolate the cube root. There's 2 of them. So I'm just going to go ahead and cube both sides. So 2 cubed is 8. 8 times the cube root cubed is just 3x plus 2. And the other side is just 4x minus 9. So I need to distribute. It's going to be 24x plus 16 equals 4x minus 9. And I have more x's on the left side, so I'm going to move 4x over. So that means I'm going to move my constants to the right. So I have 20x equals -25. So when I divide by 20, I get -5/4. Which is the same thing as -1.25. So again, I'm going to check it. 2 math 4. I'm going to type it in as a decimal. That gives me that. So the next side, or the other side, math 4. 4 times -1.25 minus, oops, let me close my parentheses, minus 9. So I get the same response. So that tells me that -1.25 is correct. And so either way I write it, if I use a decimal or a fraction, it's going to tell me that both sides are equivalent for that x value. So that tells me that -5/4 is correct. So then number 3 is very similar to 2. This time I have a cube instead of a cube root. So that means I'm going to cube root both sides. So So on the left, I just get what's inside. And on the right, I get the cube root of 27, which is 3, times 4x. Because the cube and the cube root undo each other and leave me what's inside of the cube. Now I'm going to distribute. So I get x plus 33 equals 12x. And I have more x's on the right side. So now I have 33 equals 11x. If I divide by 11, I get that x is 3. So then these are a doozy. So I have the cube and the cube root in the same equation. So I'm going to focus on the outermost set of parentheses. So I don't have anything on the front, so I have a cube, so I can directly cube root both sides. So on the inside comes out, so I have 3 times x minus 3 to the 1/3 plus 7 is equal to 28. So now it becomes a problem like we had previous. I'm going to subtract 7. Divide by 3. And then cube. And then add 3. So these three are like 9 and 10 on the back of 6-5. So this one, I'm going to cube both sides. And I get 4 plus 12 times 2x minus 11 cubed is equal to negative 8. So I need to subtract 4. Oops, that's cubed. Is equal to negative 12. Divide by 12. And I get 2x minus 11 cubed equals negative 1. So I'm going to take the cube root of that. I have 2x minus 11 equals negative 1. So I'm going to add 11 to both sides, and I get 2x equals 10. So divide that by 2, I get x equals 5. So this one I'm going to check. I need to make sure that my parentheses in the right places. 4 plus 12, 2 times 5 minus 11 cubed raised to the 1/3. Or I could have done math for 4 plus 12, 2 times 5 minus 11 cubed. I'm missing a set of parentheses. No, I'm not. So either way you write it, you still get -2, which is in the problem. So 5 works out. So in the last one, I'm multiplying by 1/2, which is the same thing as dividing by 2. So I'm going to multiply both sides by 2. So I need to take a cube root of both sides. Then we'll subtract 1. Divide by 5. And then cube both sides. So that gives me 3x minus 27 equals -27. So when I add 27 to both sides, I get 3x equals 0. So 3 times some number equals 0, that number has to be 0.